do we do synthesis? Well, the first thing we need is to spell it correctly. Let's spell synthesis. Synthesis is when you get single frequencies and put them together. Okay? So if you're talking about a guitar, an instrument, if you pluck single strings, each one is a single frequency, if you plug them together in a chord, that would be a synthesis. In practical terms, what you're doing is you have to add the individual, let's try to put better handwriting here. Individual contributions from each frequency. Okay. Again, I'm going to use both the real form and the complex form here. Although I do want to move away from the real form as we go along. The real form, let me move back one more. The real form is the form exactly here on top. This is the real form. And this is the complex form. Okay? I'm going to write both. So, let's see. Let's add frequency in real form. Let's say the frequencies are omega 1, omega 2, omega 3. These are angular frequencies. Okay? And there's a final one here, let me call it omega n. These are angular frequencies. So I'm going to write something like this. I'm going to use lowercase letters just because you mentioned. So I'm going to write A1 cosine omega 1 t plus B1 sine omega 1 t. And that is the contribution for frequency omega 1. The values of A1 and B1, these are two numbers, okay, have to do with how present that frequency is in the synthesis. If they're very large, you're going to hear that frequency very loud. And if they're very small, faint. Okay? Plus. And because the board is only so large, I'm going to put underneath A2 cosine omega 1t plus B2. Oops. Omega 2. I already have frequency omega 1 in there. B2 sine omega 2 plus A10 cosine omega n plus En sine omega nt, and that's it. Okay. Those frequencies are present. They are present each with their own intensity or strength. Okay? And you add them. So if you have a machine that can do that, produce a single frequency, okay, and add them up, you would in the end here introduce somewhere here. Very well. Now I'm going to write the same thing but in complex notation. How do you do that? each one of these is going to be turned into its complex counterpart, okay? So, let's see. Just concentrate on the first one. A1 on 2 plus J D1 on 2. A1 D1 D negative J omega 1 T plus A1 on 2 minus J D1 on 2 D J on 1 D. This green line over here is exactly the same as this box red equation here. It's exactly the same, meaning it gives you real values. It's a real sound, but it's written in complex notation. Okay? And how we know that is because of this that we did last week. Now I'm going to just take out here, and I'm going to write d2 star e to the negative j omega 2t plus d2 e to the j omega 2 plus, etc. There's a formula for the d in terms of the a's and the b's. I'm not going to write it again because it's already written here at the very bottom. There's a dn star with a negative j omega n t plus dn e to the j omega n. And there you have it. Same thing. But this time in complex. Notation. Notation. All right? All right. Can you add infinitely many? This one has only finitely many frequencies present. Can you write something that has infinitely many frequencies present? Can you synthesize something that has infinitely many frequencies? Well, let's see. In principle, maybe. Okay? No problem. How much, I didn't say anything about this, but I will later. How much energy does the first frequency, omega 1 in here, is carrying? Each frequency carries an amount of energy with it, okay? Now, how much frequency does that carry? You can compute that. We're going to do that later in the course, okay? And it has to do with these coefficients A1 and B1 in here, right? And how much frequency? How much energy does the second frequency carry? Now, it turns out that we're going to prove this. Each frequency is a carrier of energy. And you can break up the total energy into each frequency. You don't have an amount of energy that is being transported at the same time by this frequency and by that frequency. You don't do piggyback like that. Each frequency, they carry their energy. So if it is possible to add infinitely many frequencies, if each frequency carried, say, the same amount of energy, you would have infinite energy. Right? No. We don't allow infinite energy. Okay? We only allow finite energy. So, if we only allow finite energy and we want to carry infinitely many frequencies, then the individual frequencies have to carry less and less energy. Okay? So yes, it will be possible to do, but the frequencies will have to be present less and less. You can't have, say, every frequency present in the same way. No, not in practice. Theoretically, and later in the class, we're going to see that not only you can do it theoretically, but it's even useful to think about. Okay? I'm moving to the last bit of the course. White noise is a type of signal where every frequency is present equally. Because it's white noise, right? Everything's kind of randomly at the same level. So white noise doesn't really exist, but as a theoretical construct, it does. You do have things that are very, very like white noise in practice. So it's a trade-off. Things in theoretical terms, white noise really, really doesn't exist, but you have noise that is quite like it. So you think in theoretical terms, use that theoretical idea, work with it, and you get results. So I just fast forward the course a few months now. We're going to come back to this sort of view. Wow, looks like science fiction. At the moment, yes. Don't worry. So that's all I have to say about synthesis at the moment. Okay? If you know the frequencies you want, and you know the energy you want, or the intensity you want for each individual frequency, all you need to do is add them up. And we are even allowing adding infinitely many of those up, as long as you make sure that you don't get the energy to mean.